So let's solve question number 34 from the NEET question paper. The question says that there is a battery with an EMF E and internal resistance R, and this battery is connected in series with n resistances, each with resistance R. So in series, the equivalent resistance of all those n batteries, n resistances, would become NR, and in this case, the current drawn from the battery is I. And when these NR resistances are connected in parallel to the battery, and in that case the current drawn is 10I, and the equivalent resistance when they are connected in parallel would become R by N, and the battery still has an EMF of E and internal resistance of R. And we have to find, for these cases, we have to find the value of N. So let us calculate current for this case first. So the current would be given by I is equal to total EMF E divided by the sum of all the resistances, that is internal resistance of battery and the N resistors. So it would be R, this is for the internal resistance, plus NR for N resistances. It would become E upon 1 plus N into R. So doing the same thing for parallel, the current would be 10I, which is equal to net EMF E divided by the equivalent resistance of all the parallel resistors, that is R by N, plus the internal resistance of battery R. Now let's put this value of R here. We would get 10 E upon 1 plus N R is equal to E upon R by N plus R. So we'll simplify this very quickly. All the R's will get cancelled. So we have NE upon 1 plus N and 10E upon 1 plus N. So the whole fraction would get cancelled from both the sides, and we'll get 10 is equal to N, and that is your answer. So when we solve this, we get N's value is equal to 10, and that is your answer. So when we have 10 resistance in series and parallel, we'll follow these conditions, and this is option 2 in your question paper.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.